Oh. All right, guys. So, plan for the rest of the time. I'm going to go over the sheet. I'm going to collect those sheets from you, and then we're going to do a little bit of statistics, and then we're going to call it a day. It's going to be plenty enough for a freaking Monday after break. Shoulder you right back into it. Who's got 1A? What's the idea for perimeter of any object, for example? So add up for any object in the universe. How do you find the perimeter? Add up all the sides. The one object that gets very difficult for is a freaking circle. Because how many sides does a circle have? You could look at it as either it's got one side or it's got an infinite number of sides, and that gets freaky. So let me not do that to you, I'm sorry. Okay. Infinity might come up a few times. So for the triangle, for any shape, if I know all the side lengths, the perimeter is easy as shit. So what do you guys get for the perimeter for part A? 48. 48 centimeters. Thankfully, I didn't make one of these like meters or something evil, right? So that's what you have to look out for. And the problem is make sure that all the units are the same. Some of you guys are now realizing how horribly I write, so good luck to you. How about the area of a triangle? Yeah, 1/2 length times width, or 1/2 base times height. Every triangle is half of a shape called a parallelogram. A rectangle is a special parallelogram where the angles are 90 degrees. So you guys know with me? What's a parallelogram?
Where they have two sets of
Parallel
lines.
yeah. There you go. So a rectangle you can think of as this goes straight up, and then a parallelogram is if somebody sat on it and the poor thing kind of shifted over. You guys kind of with me? So every triangle in our geometry is half of an associated parallelogram, and every area of every parallelogram is base times height. Of course, it's 1/2 base times height. You guys kind of with me? So for this one, you can imagine if you filled out the rectangle, it would just be 12 times 16, and that's exactly half of that big ass rectangle. Okay. So 1/2, 12 times 16, which is 6 times 16, which is 96. 96 what?
Centimeters squared.
Centimeter squared! Kick ass. Coming in strong on that one, I like it. It's kind of silly. Centimeter times centimeter is centimeter squared. So what units is volume in? Area is square units, volume is cubic units. Kick ass. Some of you remember circles, right? The circle's not impressed. What's the thing with circles? What is it that shows up in anything that has to do with circles very often? What could show up?
Pi.
Pi. And what the hell is pi?
It's a mini after.
It's a yummy thing. Push a whipped cream on it and you have a good day. Does anybody know where pi came from? It's the size of the O. You do? What's that? Where did pi come from?
It's the diameter 3.1415 times around the circle.
Okay. So the radius. So if you take the radius and you say, all right, stay with me. This is cool. If you take the radius and you bend it and you put it on the circle, you with me? And then you do that again, and then you do that again. 3 radii will go this far around. And then if you do 0.14, it'll go all the way around. So pi is roughly 3.14. Now, obviously, very quickly, what is pi really? Does it ever stop? 3.1415, blah, 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 right? So March 14th, 2015 was a big day for us math geeks. That's what we call Super Pi Day, because pi is 3.1415, 96, blah, blah, blah. You guys got a little peek into the life of freaky ass math nerds like me. Okay. So pi comes from, the real place pi came from, is civilizations discovered that no matter how big or small a circle, if you take its circumference divided by its diameter, you always got the same number. Now, if you imagine, back in the day, before we had any real mathematics set, and people are starting to play around with shapes, and they say, holy shit, this circle, if I take the circumference divided by diameter, and this circle, if I take the circumference divided by diameter, we get the same damn number. Would that not have freaked you out just a little bit? If you were a civilization that relied heavily on religion, you might say, oh, this came from God, and you might call it gold and stuff, you might call it whatever. So a lot of civilizations had approximations for pi. You guys kind of with me? Egyptians had an approximation 22/7. What is 22 divided by 7? Anybody? Anybody? You're all like, you're the math boy, you do it. No? So you can do it. 22 divided by 7? No pressure, sorry. I love you guys. 22 divided by 7. What's happening right now? Can you guys do it?
3 point. Oh, is it 3.14?
Yeah?
Is it?
3.14. 2.8, blah, blah, blah. Okay, good. That's not high, but that's pretty damn close, right? That was an exciting moment. Thank you so much. I'm sorry, I might not have been clear with what I wanted you to do. So the Egyptians, considering they didn't have supercomputers, they had nothing. That's pretty freaking close. Holy shit. And the Greeks were very interested in this. A lot of people had area formulas for multi-sided, like hexagons and so forth. So if you give something 1 billion sides, you can approximate a circle very quickly. I don't know if you guys are really with me. You all have seen stop signs. Yes? Okay, so later this semester we're going to identify and categorize different, how many sides that it has is going to help us categorize them, right? Like pentagons and hexagons and so forth. So can you imagine I can make the sides very tiny and I can end up with like 5,000, yes? Can you imagine that? One little side and then another little side and then another little side and then, holy shit, I'm nowhere near done. You guys with me? And you can have a formula for the freaking area of that, or the perimeter. This is what I meant by you can consider a circle to have an infinite number of sides. Because the circle is what you get when you let the side become infinitesimally small. I promised I wouldn't do that, I'm sorry. But is anybody roughly with me? This is nothing you have to know, I'm just letting you know. So, with all that said, if I take the circumference divided by the diameter, I get pi. And so all we did there was we multiplied the diameter up and we got the formula for the circumference. And circumference is just the name we give to a circle's perimeter. You guys, is this all kind of coming back? Okay. I like this, and again, I didn't want to freak you out, but my warm-up sheet, I'm always of two minds about it. I don't want you to feel like you're behind if you forgot it, but I want you to start bringing it back up. Because I know you guys have done this before, but for some of us, it's been a long time. I understand. And I'm a freaking math dude. I do all this shit all the time, so it's not fair. So then if I throw this in, what's the diameter? 12 pi feet. And then if I approximate it in my calculator, what do you guys get? Is it 36.4 or something?
37.68.
37.68, okay. Blah, 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 blah. What about the area of a circle? God, I can talk a lot.
Radius squared.
Yes, now why the shit is it that? Pi r squared. Does that sound familiar? And you got this silly joke about pi r squared, pi r round. Has anybody ever seen why that's true? Why the area formula for a circle is pi r squared? I can see some of your eyes, you're like, I don't need to know, but I'm going to tell you. All right, so if I have a circle, oh no, if I have a pen that has ink. Okay, I've got a diameter, and I've got a radius. Now, real quick, I'm going to go this a little quickly. If you cut little triangular shapes, so what I want to do is I want to cut down the diameter and then cut out to the outside, but not through the outside. So like you're making a doily kind of thing, if you guys are, where you open it up, it's little dudes holding hands. You know, oh, look at that. So I'm going to cut down the center, and then I'm going to cut out, but not through the outside. And then I can lift it up and open it up. So it looks like top teeth there. Oh, yes? So if I pick this up and I put it over here, it'll look like this. Rough. Pick this up, open it up, and there it is, yes? Now, all the way around the circle is, what's the circumference around that circle? Take a bunch of dead pens. What did we just say the circumference was? Pi b. And how does the diameter relate to the radius? Yeah, the radius is half, yes? So the diameter is twice the radius. You guys with me? So I have to replace the diameter with twice the radius. I don't know if you guys remember this formula for the circumference. Okay, you guys all with me? So all the way around the circle is 2 pi r. So what is it from here to there? What is that much? If all the way around is 2 pi r, that much is pi r. Okay. All right, let me see if you guys are really with me. So I chopped through, but not through the ends. I chopped this, I chopped them, and then I picked it up and I put it there. So how long is this? Pi r, kick ass, because that's exactly this. I've just opened it up, straightened it out. Yes? So this is pi r. If I do the same thing to the bottom, chop, 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 open it up and stick it in like this. There. Now, this is not perfect, but if I make a lot of triangles, if I make a lot of little tiny skinny triangles, what happens here, how tall is this roughly? What is this? How tall is this roughly? The radius. You guys see that? So what I've done, I've taken an area I don't know, and I've morphed it into an area that I do know. The area hasn't changed because it's the same cookie dough. I've just shaped it different, yeah? What is the area of that rectangle? What's the area of any rectangle? Length times height, right? And length times width. So what's the area of that rectangle? Pi r squared. Pi r times r. Okay. So we're going to see stuff like this semester. You can take a shape. You can cut it into shapes you know. A shape we don't know, cut it into shapes you know. And then you can figure out the area of the original shape. Or like the one we saw, the third problem, you can take a shape, chop it, and then you have parts that you know. Then you can add those back together. So coming back to this, the area would be pi. What's the radius? 6, good. So you get 36 pi. What's the units? Good. And that's approximately whatever the hell that is times 3. 109.07. I don't know, I'm guessing. Whatever. What's 36 times pi? Okay, I'm learning now. I have to do my
113 point something.
113 point stuff?
Yeah.
Okay. I like it. This last one, I don't think, did anybody do it different than this? What'd you do, Kendall?
I know the little triangle, the missing part.
Oh, so you filled in the missing part here.
Yeah.
Okay, I like it. So if you do this, this becomes 14, right?
Yeah.
And then how'd you go from there? So you kind of filled in the missing part.
Well, I did based on say the triangle, so I did 5 times 12 divided by half.
Yes.
And then I took that out.
Good. Okay, so this is different from what I saw a lot of other people doing. So you did 14 times 12, yes? For the whole thing?
Yeah.
And then you took out that triangle.
Yeah.
Kick ass. Because I think what most of you did was, which is fine, not a damn thing wrong with either way. You did this rectangle plus this triangle, yes? If you do it either way, you get the same thing, of course. So 14 times 12 minus 1/2 times 5 times 12. Which will be, I don't know, what will that be? 138. So that's the same answer you get either way you do that. But I don't think anybody, and I don't blame you for this, that is also a trapezoid. You know, that's good for it. Does anyone remember why is that a trapezoid? Does anyone remember anything about trapezoids besides the fact that you forgot everything about trapezoids? Anybody remember anything about trapezoids? Trapezoids require, no. Trapezoid require 2 parallel lines, and then the other lines they do whatever the other lines. So a very standard trapezoid would be this kind of a shape, yes? That's your standard kind of trapezoid. It's often called an isosceles trapezoid because the angles down here are the same. You guys similar with me? So, very quick word about a trapezoid. I'm not going to spend too much time on this. A trapezoid, like a standard trapezoid like this, doesn't it look like a beheaded? Sure, Jeff. A beheaded triangle. Poor little triangle. What did you do in math today? We beheaded triangle. Formula for a triangle is 1/2 height times base. How many bases does a trapezoid have? Couldn't you just turn that over? Isn't there 2 bases? There's like a top base and a bottom base, right? You could turn that sucker over if it's a bowl. So the formula for a trapezoid is 1/2 height times the sum of the bases. Because this dude's got 2 bases. There's a whole proof to it. I'm not going to go through it right now. Because understandably, you guys are approaching being mathed out for the day. I understand. So either way you did this, you should have gotten, what was it, 138? What?
It's just squares.
It's just squared. And what's the perimeter of this? Perimeter of this would be, yeah, you just have to add up all the sides. So you get 14 plus 12 plus 9 plus 13. Add all that up. You guys kind of with me? You just have to add up all the sides. What about number 2? I think I got everybody to the point where they got this one. More often than not, the math we do is translated directly from the English we say. So in English, how many out of how many? How would you rephrase this? How many out of how many? Do something specific. 5 out of 40, you're left-handed. That's exactly the math you do, 5 divided by 40. Where do you think a student would get 8% from? Why do you think I would get an answer of 8%? Yeah, they did 40 divided by 5 because the brain said, hey dude, you can't divide 5 by 40, man. What the hell are you talking about? It must be 40 divided by 5. You guys you're gonna see this thing a lot if you're teaching the lower grades because they're not used to 40 being able to go into 5. And you guys talk about all that in Math 125. So you have several ways to explain why that makes sense. Now if you do 5 divided by 40, what do you get? You get 0.125. And then how do I convert that into a percentage? Move the decimal twice over. Real quick, what's the percentage symbol mean? Percent per 100. That's why a percentage number will always be bigger than the decimal number because the percentage number has not been divided yet by 100. Does that make sense? Okay, there's going to be a lot of percentages floating around in the first couple chapters. Just to let you know. Number 3, I saw a lot of different approaches to this. How many of you guys used algebra on number 3? Oh, thank you. I love it. Not surprisingly, this little math geek up here is always happy when algebra is getting used in the wild. It's not really the wild, but how many guys did this more guessing and checking? Okay, which is a valid method. You learned in Math 125, which students have used for all of eternity. And how many guys used something a little more formulaic, but it wasn't algebra? How many guys think you did that? Anybody? And the rest of you guys, did you get the answer? Go ahead. Okay. So a very common way to do this. Let me ask you this: If three numbers average to be 80, do we know what any of the numbers have to be? If generally, just three numbers, average to be 80, do we know what any of the numbers are? Do we know what they add up to be? What's the only way three numbers can average to be 80? How do you find the average of three numbers? Add them up. Divide by 3. What's the only number you divide by 3 to get 80? 240. I do not know what that third test grade is, but I know that all the test grades together better add up to be 240, because that's the only way I can divide by 3 to get an 80 average. You guys kind of with me? That is probably the most, besides algebra, that's the one that students do a lot. Now, if you didn't realize this, it's okay, because you don't use averages a lot. You're going to be teachers, especially if you're going to teach higher level. You're going to want to be able to analyze your students' work, get general trends. You're going to want to know a little bit of statistics so you can kind of see what's going on and see how to improve. So in this one, there's a few different ways. If you do algebra, it's this way. What's the third test grade? I don't know. But whatever it is, I would add them up, divide by 3, and get 80. Yes? So then you get 153 plus x equals multiply. Does this sound familiar? This is basically what we just said. If you don't do it with algebra, you basically do algebra without realizing it. You say they have to add up to be 240, and then you subtract what you already have. Yes? So what's 240 minus 153?
87.
87. Now let me show you my freaky ass way to do this. You have to average to be 80. What's the easiest way for three numbers to average to be 80? They're all 80. What if they're all 80? With me, can you all see three 80s in your mind's eye? Yes, you see them all lined up, little commas in between even to make it all grammatically correct. Make one of them 79. The last one better become what? So the average is still 80. 81. You with me? So, using that thought, how far from 80 is the first grade? It's up 2, yes? How far from 80 is the second grade? 9 down. So how far from 80 am I total? 7 down. So this better be 7 up. You guys with me? Now, my day has been made right now. I need you to understand this. Because I saw somebody in the back go, oh. That's all it takes for me, is to have one person go, oh. And I'm happy. Now some of you guys are like, okay. That's kind of manipulative. So we are going to be analyzing data. We're going to be calculating average. We're going to be creating graphs of data. It's going to be, I'm going to love it. I don't know, we'll find out. Okay. Any questions from this whole thing? All right, so real quick, slap your name on there. Let me collect those. I can have my first little group of papers from you guys. If you want to, you can head back to your desk. Sorry. I'm gonna get back to the groove of this. Okay. So guys, I started using this iPad last semester. I'm gonna try this semester to actually upload the notes I do and then have those also available on campus. You guys kind of with me? So we'll see how that goes. I'm pretty good with technology, but Apple products I don't use too often. So why did I get this? Because I had a discount for it, and because most of the school stuff is Apple related from the fine art stuff. Anyway, so we'll see if Jeff can do this. So what I want to start off with, let me ask you guys this. If you wanted, is there something you would like to know about Grossmont students? Like, for example, a boring example would be, what percentage of Grossmont students smoke? Is there something you would be curious about to know about Grossmont students in general? Anything? Allergies. So like, I like this.
People allergic to
So the first, maybe let's make this, can you make it numerical somehow?
Peanuts.
The percentage of Grossmont students who are allergic to peanuts. I like it. Okay. You guys all with me?
Yeah.
So obviously, this is really silly, but before I can do a statistical analysis, I have to freaking have an idea of what I want to analyze. So the first step in a statistical experiment is to formulate a question, right? So the question that was just formulated was, I wonder what percentage of Grossmont students are allergic to peanuts, right? You guys go. And some of you guys are sitting there like, I don't care about that. That's what came up. You had your chance. So the first step of any statistical analysis is to formulate a question. Oh yeah, one of this. Holy crap and a half. All right, it's not going to help. You don't write well. You should at least spell. Formulate a question. So our question is, what percentage of Grossmont students are allergic to peanuts? No, I just want that. Oh my God. All right, I have left out a little time. Holy crap. So, even though maybe you've never taken statistics before, I know you know some basic things. How could we start to analyze that? How could we start to get an answer to that? What would we do? All right, a really good starting place would be potentially the total number of students who are going to Grossmont. Now, once upon a time, that was rough. That was hitting 20,000. I think we're currently down to like 12,000, 11,000. We didn't quite make it back from the pandemic too well, so we're doing what we can. That would be useful if you had access to every Grossmont student. So if you're doing this on your own, do you want to talk to every Grossmont student? Because like I just said, there's roughly 11,000, right?
So in class.
Oh, okay. All right, look, you guys kind of with me what's happening? So if you, tell me, does somebody know the specific name for all Grossmont students related to our analysis? The collection of everybody we want to say something about. What's the name for that?
The population?
Population, kick ass. So in this case, the population is all Grossmont students. So you, oh my God. This is what over a month off does to me. That's particularly bad for me, right? Listen to what I say, not what I write. I've told students before, if I ever get to the point where you ask me what I wrote, and I'm like, I don't know what I wrote, I should retire, I should go away. But I can still read my own writing, which is great. So the population is all Grossmont students. We don't have time or resources to talk to every single Grossmont student. So what do we do in that case? We take a sample, kick ass. And the sample will be the actual students we talk to. Actual group analyzed. Now, why would it not be good to, let me see, how do I say this? There's no great way for this population to shoot. If I wanted to say something about people that live in San Diego, and I go to the beach and I interview 30 people, Why might that not be a good sample? Say again? Tourists. So the main thing you want your sample to do is to be a subset of the population, yes? You don't want your sample to be biased by other populations. Does that make sense? So a sample has to be a subset of the population. Most of what we're talking about, I think I turned on the pencil, neat. Most of what we're talking about up here should all be stuff you've heard a little bit about before. You know population, you know sample. And most of us in here should understand that samples can be good or bad. What makes a sample good? What makes a sample good? Why would this class, if I use this class to analyze our question, why would that not be a good sample? Does that mean you're not good people?
No.
Why is this class not a good sample? Who are we trying to talk about? All gross 1 students. We don't have the time to talk to all gross 1 students, so we're trying to represent all gross 1 students with a sample. So why would this class not be a good sample?
Because it's just all people in the same class.
There are connections of why people are here. Number one, this is an on-ground class. I love that phrase. Have you ever heard that phrase before? We have classes that are online, and we have classes that are on ground. First thing I think of is freaking floating in the air. But is class on ground? No, we're floating above this. No, sorry, silly phrase to me. You guys are on ground. You guys are here in the daytime. You guys are here for a specific reason, for a specific major. Could there be things that might bias the results? Even if we can't say there are, it's still a bad sample because it's not representative of the population. You guys kind of. So what's our goal for any sample we take? We need to do everything we can to make it representative. So anybody have a suggestion as to how to make it better? Yes?
English 120.
What about English 120?
Like they look at English 120 class in the population.
All right, so if I took this class and added an English 120 students in,
Straight up English 120.
oh, just English 120, would that be a better sample?
I think everyone does take it. Yeah.
Oh, I see your point. So that would be better. Would it be good? Does everybody actually have to take English 120? You sure?
Yeah.
You sure? Aren't there people that come here with AP credit in English?
Or like Mesa credit.
Mesa credit? Yes? You guys kind of with me? All right, no, real quick. I love it. That's beautiful. More people have to take, but if you take one class, which class? What time? You're leaving people out that can't take a class during that time. You with me? Okay. You guys kind of understand, we're not going to get too deep into any of this, to be honest, because we don't have all the time in the world to cover this. But if you're trying to design a survey or you're trying to answer a general statistical question, sample picking is the biggest part of it. It is the part that you need to address immediately in any journal article you write. You must address how you chose the sample. So then I can see if I think that you're representative and I can trust your results. You guys kind of with me? Okay, you're all in. I'm still waiting to see what this means for me. I'm gonna want you guys to know basic definitions. I don't ask definition questions. I ask questions that show me you know what the words mean. Does that make sense? Like if I say find a sample in this situation and you give me the right answer, I can infer that you understand what a sample is. Okay, I'm not gonna ask you define sample. I don't like that shit. Okay. So a sample in general is a subset of a population, but what makes a sample better is if it's representative. And how do you make a sample representative? How do you choose people to be in our sample? What's the best way to make the sample representative? So we started going with, okay, this class is not good because not everybody has to take this class. So Kendall beautifully went a step up. Why don't we pick a class that base almost everybody has to take? Right? Okay, that's better. Immediately. All right, but why not take random samples of students from every English 120 class? Would that be even better? Because then you're eliminating the chance that you're picking only people that can take a class at a certain time of day, in a certain format. We're going to take online students also. You guys kind of with me? Okay. So what you're trying to approach is something called a random sample. And what a random sample is every element of the population has an equal chance to get into the sample. Let me say that again. A random sample is one where every element of the population has an equal chance to get into the sample. So if I was just using this class, does every gross fund student have a chance to get into the sample? No, because not everybody majors in elementary education. Not everybody is here at this time. Not everybody takes on-ground court. A bunch of stuff, yes? So I want to try to select a sample in a way that every element of the population has a chance. Okay, so far so good. So the first step, we're starting into the second step now. First step is formulate a question, and the question, the second step we sort of already started doing. What's the second step really? What are we going to do from this sample? Once I get a sample of people, what am I going to do with them?
Analyze it.
In what way? I'm just going to stare at them intently?
Ask them a question.
Ask them a question. So you're going to start to collect data. Kick ass. Okay. So you formulate a question, first step. Second step, you collect your data. There's more details involved, of course, like we just said. How do you collect your data? Well, that's a huge part of it. If you collect your data in a bad way, nobody can trust your results. I like it. Oh my goodness. Now, so we're going to ask people what question? Specific to our analysis we want to do. What are we going to ask you? Are you allergic to peanuts? Yes? And what are people going to tell us? What's the data that we're going to collect? Yes or no? Yes or no? Amazing. What's the immediate thing we can do visually with that data? There could be some people that say, I don't know. So we might as well put that in there. And then an unethical thing to do would be to feed them peanuts and see what happens, so we wouldn't do that. Let's find out. Oh shit. That's a yes. Not a good way to do statistics. So real quick, this is kind of silly because we only have two things, but, well, three really. Could I make a picture like this maybe? Yeah. Yes, no, I don't know. Bless you.
Thank you.
Most of us probably would know because it's hard to avoid. If you are allergic to peanuts, you know all too well how difficult it is to avoid them. Many things that don't have peanuts are made where peanuts are used, and you're like, holy shit. Does anyone know what the name of this kind of graph is?
A bar graph.
That's crazy. All right. Celebrate the little victories. I love it. So it's a graph of bars. So of course, math people were very creative in our naming. Going, let's call it a bar graph. Good. Notice the scale, the x-axis scale. What kind of data is that? Is it numerical or non-numerical? The x-axis scale.
Non-numerical.
Yeah, this is non-numerical. So bar graphs are primarily used for non-numerical data. Like I can ask what kind of car do you drive? Could be Mercedes, BMW. I don't know why I think Yugo. Why not? I'll be used Yugo. Okay, you guys kind of with me? And I can have little bars. Yeah. So you all have heard of bar graphs before. So the third step, and I made this way too specific, is to display and organize data. Display and organize data. We haven't analyzed the data yet. If I make a bar graph, have we answered our question? What was our question? What percentage of freshman students are allergic to peanuts? Have we answered the question yet? If we make a little bar graph. No, we haven't done that at all. Good job, us. But a really good step in any analysis is to just display the data you collected. Just so other people can make their own analysis if they want to double check what you did. Obviously, hope to God, this is bad. If you gave me this as an answer to something, why is this bad?
Because there's no numbers.
no freaking numbers. How, it's like, all right, I can tell that there's more no's, but I have no idea how many more no's. So I want some scale. I want the scale to be consistent, right? Don't go 5, 10, 30, 31, 32, 87. I've had students do that all the time, and it makes a straight line. Well, yeah, sure it does, because your scale isn't right. You guys kind of. And again, if you've taken stats before, hopefully this is all very familiar. This is some of the first stuff you do in a stats class. Blah, 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 blah. Oh, did I forget something here? Sort of. So let me introduce one last thing we'll do, and then I'll let you guys out of here. I'm going to introduce a very, very basic way to give a visual of data. So let's say I have this data here. 14, 17, 18. This is exciting. Nobody will be seated during the Jeff Makes Up Data section. Okay. So let's say this is ages of students in a college classroom. Look at this kid. Wow. You can see how they're going. What's the youngest? I think the youngest I've ever had is 15. And the oldest I ever had was 87. I'll never forget him. He was hurt. He said, I can't come to class because I was bitten by a moray eel when I was scuba diving. I'm like, I want to be that when I'm 87. I want to be that when I'm freaking 15. Huh?
Why was he in a college class at 87?
I think
Because he wanted to
well,
be.
people get bored.
Hell yeah.
Not me, yeah.
Big time. Okay. All right. So we got that data down, 14, 17, so these are ages of people. I can even say just standing at a bus stop, whatever. One of the most basic, quick visuals of data that you can give is called a stem and leaf plot. Anybody, I get some looks of recognition out there. Stem and leaf plot. Right? My stems. This data has stems and leaves. There are numbers that are associated with other numbers, and those first numbers happen more often. So what am I saying? Aren't there numbers in the teens? Yeah. Isn't 1 showing up often? Aren't there leaves coming off of that 1? So I can say, if the stem is 1, what are the leaves? What numbers are coming after 1? 4, 7, 8, 8, 8. And what numbers are coming after 2? 0, 1, 2, 4, 5, 6, 6, 7. What about after 3? 1, 4. I think I'm okay. Yeah, I did okay. Now I can't do this with this because if I do like that, it's just going to turn. But if you turn your head, doesn't it make sort of like a bar graph? If you just imagine outlining where how far the numbers go. So this is a quick visual representation of the data, and it shows kind of like how the data is distributed. You guys kind of with me? And I could very quickly see if there was nobody in their 40s, but there was one crazy ass dude that might be me that's in their 50s. Then I would have like a blank spot there. See what I mean? I'd have a blank category. So I could very quickly see the outlier. And just point at me and go, outlier. You guys can come if you want. Alright, so that's a stem and leaf plot. So that's one of the most basic ways to represent data that you've collected. So next time, we'll get into analyzing the data, calculating percentages, stuff like that. If you don't have your own calculator, you can get one that does 500 things for $14. It's crazy. So one of the little scientific calculators is very cheap. If you need any help getting a calculator, let me know. But I will always bring one of my bags here with calculators in case you need to borrow one. Okay? If anybody has any questions, then come on up. Otherwise, I'll see you guys on Thursday. I'm sorry, Wednesday. Wednesday. Good to see you again.
Barely, but yeah.